Hi everyone, today we will be talking about de Moivre's theorem. De Moivre's theorem is a fundamental result in complex numbers named after the French mathematician Abraham de Moivre. It provides a way to raise complex numbers to integer powers, which is particularly useful when working with trigonometric functions. Basically, if you have a complex number z written in polar form, raising it to the power of n is the same as raising its modulus r to the power of n and multiplying its argument theta by n. This theorem provides a convenient way to calculate powers of complex numbers without having to resort to Cartesian form, which is the a plus bi form, and without needing to use trigonometric identities repeatedly. It's particularly handy when dealing with repetitive calculations involving trigonometric functions. Think of it as just another tool in your toolbox for tackling trigonometric equations and functions. For example, let's say you want to find 1 plus I to the power of 10. You could totally just expand the expression manually, and then you could simplify. That will take you a really long time, and there's a really high chance of error. Instead, you could use de Moivre's theorem, convert 1 plus I into polar form using the theorem, and you will find the answer much more easily. So let's walk through how we could solve this problem. First, we need to express 1 plus I in polar form. We can first find the modulus, and then we can find the argument. The modulus r of 1 plus I is a square root of the sum of the squares of its real and imaginary parts, which is a square root of 1 squared plus 1 squared, which equals the square root of 2. The argument theta can be found using trigonometry. Since we know that tan of theta equals 1, theta equals pi over 4 in radians. Therefore, the polar form of 1 plus I is this. We can apply de Moivre's theorem. And then finally, we can simplify the trigonometric functions. Using de Moivre's theorem, we were able to find that 1 plus I to the power of 10 equals 32i. And that totally beats completely manually expanding the exponent in our normal way of doing math. Thank you.